Decomposing a monolithic application into microservices is a complex process that requires careful planning and understanding of both the application's domain and technical architecture. The goal is to break the application down into smaller, independent services that align with business functions while ensuring that these services can evolve independently. I'm Balaji Chandrasekharan and going to explain the step-by-step approach to decompose an application into microservices. Please like, share my video, and subscribe my channel. Understand the domain. One of the most popular approaches for breaking down applications into microservices is domain-driven design, DDD. It helps to understand the business domain and divide it into distinct areas, often referred to as bounded contexts. Bounded context is a logical boundary within which a particular model is defined and applicable. For example, in an e-commerce system, you might have separate bounded contexts for order management, inventory, and user authentication. Define the core entities and aggregates, collections of objects that are bound together, within each bounded context. These will help determine where logical service boundaries should exist. Steps. Break down the business into key domains, example user management, payment, product catalog. For each domain, define its boundary and ensure it is self-contained. Once you understand the domain, identify core features and functionalities that can be separated into distinct services. What are the core operations of the business? For example, if you are working on a banking system, services might include account management, transactions, and notifications. Think in terms of modules, where each module represents a potential microservice. Each module should handle a specific function, example billing, inventory, search, etc. Start small, begin by breaking off the least interdependent feature as a standalone microservice. This will help avoid overwhelming complexity early on. Analyze dependencies. Look for tightly coupled components within the monolith that can be decoupled. Understanding data and service dependencies is critical to decomposing successfully. Many monolithic applications share a single database, so you'll need to identify which components depend on which tables or entities and decide how to split the database into separate data stores for each microservice. Each microservice should manage its own database or data store to avoid coupling services through a shared database. Define service boundaries. Services should be loosely coupled, meaning that each service should be as independent as possible. Changes in one service should not necessitate changes in others. Each microservice should do one thing and do it well. For example, a payment service should only handle payment processing, not user management or notifications. Ensure that each microservice handles a single concern or functionality. Services with overlapping concerns tend to result in tightly coupled systems. Design APIs and communication. Microservices communicate via APIs, so it is important to design clear, well-defined, and versioned APIs for each service. Use HTTP/REST for synchronous communication between services. However, consider using asynchronous communication, via messaging systems, where possible to avoid tight coupling. For communication that doesn't need to be immediate, example event-driven systems, you can use message brokers like RabbitMQ or Kafka. Consider using an API gateway as a single point of entry to route client requests to the appropriate microservices. Handle data and transactions. Each microservice should own its own data. Avoid direct data sharing between services. If multiple services need to access the same data, they should communicate through APIs rather than accessing a shared database. In distributed systems like microservices, it's difficult to maintain strict consistency across services. Instead, adopt eventual consistency principles where appropriate. Consider using sagas or compensating transactions to handle distributed transactions across microservices when necessary. Establish service contracts. A service contract is the set of APIs or communication interfaces that other services or clients interact with. It's essential to define clear, stable interfaces to prevent breaking changes when services evolve. API versioning ensures backward compatibility as services evolve. New versions of services should be created when breaking changes are introduced. Implement cross-cutting concerns. Centralized logging is essential in microservices architectures, as each service generates its own logs. Tools like ElkStack, Elasticsearch, Logstash, Kibana, or Splunk can help collect and analyze logs from multiple services. Each service should expose metrics for monitoring purposes, example through Prometheus and Grafana. This will help you track the health and performance of individual services. Implement security measures like authentication and authorization at both the API gateway and the service level. OAuth 2, JWT tokens, or other security mechanisms should be used to protect inter-service communication. Implement resilience patterns. Use circuit breaker patterns to prevent cascading failures across services. If one service fails, the circuit breaker will prevent other services from being overwhelmed. Ensure proper retries and timeouts in inter-service communication to avoid long wait times in case of service unavailability. Incremental migration strategy. The strangler pattern is a common approach to gradually refactor a monolith into microservices. The idea is to build new functionality as microservices and incrementally replace old monolithic components over time. As new microservices are created, they gradually strangle the old monolithic functionality until the monolith no longer exists. Testing. Each microservice should be thoroughly tested in isolation, unit tests, as well as tested in conjunction with other services, integration tests. Ensures that services that depend on one another communicate correctly. Tools like Pact can help enforce contract testing between services. Perform end-to-end testing to ensure the overall system works as expected when all microservices are integrated. Each of these services can be now made independent, handles its own business logic, has its own database, and can be scaled or deployed separately. Decomposing a monolithic application into microservices is a strategic process that starts with understanding the business domains, identifying service boundaries, and breaking down the monolith incrementally. It's essential to focus on maintaining loose coupling, implementing robust communication, and handling cross-cutting concerns like security and monitoring. By following the principles outlined above, you can create a flexible, scalable, and resilient microservices architecture. This concludes the end of the session and look forward to seeing you in our next one. Hope you have enjoyed the video. Don't forget to like, share, and subscribe. Thank you for tuning in.